Okay, everyone. So we are going to be looking at matter and different states that matter can appear in. So this is the start of our chemistry unit. So today is going to be very much so an introductory lesson and reviewing a lot of the terminology that you're already used to seeing when talking about matter. So just a few things. So what do we mean when we say the term matter? So matter is really anything that has a mass and takes up space or has a volume. Let me change my color here. Sure. Okay. So matter can come in one of four different phases. Now, normally we only discuss the first three: solids, liquids, and gases. So when we refer to the states of matter, this is what we're referring to, one of these three. Plasma is really a very unstable form of matter, and it's only present typically for a brief moment in time. So gases can become plasma if added energy is provided, and we'll talk a little bit more about that. So if something is not matter, so if it doesn't have a mass or take up space, that means that it is a form of energy. So basically everything in the universe is either energy or matter. So matter takes up space and has a mass and volume, and energy has no mass and no volume. Okay, so it does not take up any space. So even though a particle might be incredibly small, and we're going to talk a lot about particles, you're going to hear me use that terminology quite a bit. So we can have, let's say, one little particle of water. So there's my little H2O. So even though it's one molecule is so small that we can't see it with our naked eye, it still has a mass and it still takes up space. So matter is really a whole bunch of different things. So everything from water to air to popcorn to a pencil, a rock, your chair, everything is mostly matter. So if something is not under the category of matter, it's under the category of energy. So some examples of energy would be heat. Or infrared energy is also heat. Or electricity is a form of energy. Or light is a form of energy, right? Motion or kinetics, right? The energy of movement. These are all things that do not take up space and do not have a mass, okay? So what state of matter something is in usually is connected to how much energy the particles are in that type of matter. And we're going to look at that when we look at the different states. Okay, so the first state of matter is a solid. So solids hold their own shape, they have a mass, and they take up space. So basically, all types of matter have these statements. So solids are rarely compressible. Okay, so again, every type of solid is also unique. Okay, but in general, they hold their shape. So they don't really mold their shape depending on their container. So for example, I have this gold bar. If I want to squeeze this gold bar to make it smaller, I can't really do that under normal circumstances, right? So if we were to look at a particle picture of a solid, okay, so let's say I have here like a cube, right? So particles, and we'll talk about this when we look at the particle picture again, but I want you to get used to seeing this. So the particles of a solid are usually very compact. Okay, so you have your individual particles, and in a solid, there is not a whole lot of space between particles. You have to imagine this is all filled. So because there's not a lot of space between particles, that's why it has that characteristic of holding its own shape. Now, liquids, on the other hand, can change their shape depending on the type of container that it's in. So if I have a very tall beaker, or if I have a very shallow dish, right? If I put the same amount of liquid in here, right? So let's say I have liquid here. it's going to change shapes depending on what container it's in, or if I have it in a little test tube, right? So it will change shape depending on which container I have it in. Now, the reason why it's able to do that is because liquids have more space between particles than solids do, right? So if we were to look at the same type of cube again, right? So let's say we have a liquid. Let's say we have a liquid here. You might have more space between particles, right? So that's why they're able to flow and move easily between each other. So it's able to change shape quite easily. Now again, the same statements can be made. Liquids have a mass and they take up space because of course they're types of matter. Now gases have even more space between particles. So gases will fill whatever container or whatever vessel that it is in. So if we have a gas, let's say inside of a enclosed box, right, there's going to be lots of space between particles, much more than solids and liquids, and it will fill whatever space you give it. So if you give it in a shape like that, or maybe we give it a small shape, right, it's going to just fill the space. And again, gases have a mass and take up space. So really the only difference between these states of matter, solid, liquid, and gas, is the space between particles. So what happens is the interaction between particles is going to be different because it either has more or less space. And when we talk about particle pictures tomorrow, in the next lesson, then you'll see what we mean by that. Okay, so plasma was that last type of state that I was mentioning to you. So plasma is essentially energized gas. Okay, so plasma is essentially a gas that has extra energy to it. Okay, so it's important to note that this state of matter does not last forever. Okay, it always, in order to exist, it must always have a constant flow of extra energy. Okay, so for example, lightning is a form of plasma. So let's imagine for a second, right? So there's air, obviously, in the atmosphere. So air is a gas, right? It's a mixture of different gases. So we have oxygen, carbon dioxide, a bunch of different gases in air. Now, when you see lightning, and you can see the bolt of lightning in the sky, so let's say you're watching from somewhere safe inside, this lightning bolt that you see is a form of plasma. So what this is electricity running through the air. So remember we mentioned that electricity is a type of energy. So when you have electricity in the air, you have energized gas. So the air itself, the gas that's in air, has excess energy from the electricity, which is why we can then see that light that's given off. And plasma usually gives off light. Okay, so we also see other forms of plasma in fluorescent light bulbs or neon lights. So again, if you know anything about how light bulbs work, obviously, is that you have to have the switch turned on in order to have the light coming off of it. So let's say you have a neon sign that says open. It's not on all the time. It's only on when there is electricity running through it, right? When the switch is turned on. So plasma behaves exactly the same as gas, except the particles are electrically charged. There is extra energy in those particles. And as soon as that energy is cut off, it goes back to behaving like a regular gas particle would. Okay, so here is some particle pictures. So we're going to see these quite a bit. So again, this is a much nicer picture than the ones that I was drawing. But solid, liquid, and gas, you can see here that the space between particles is very different from each of them, right? So here you have more and more space. Now, in terms of energy of these particles, The more space between particles you have, typically the higher the energy amount is in those particles. So we'll review this when we look at particle pictures, but particles are always moving. Okay, so meaning they have movement always. Now the difference is solids move less than liquids. Liquids move less than gases. The rate at which it moves is related to how much energy they have. So gas particles are moving the most, and solid particles would be moving the least. Okay, but regardless, they're still all moving.